The last time we discussed material from Unit 4A, we were looking at an investigation into parallel lines. One of the big things that you should have pulled from that is that equations of parallel lines have the same slope. So today we're going to find a line that is parallel to the given line through a given point and graph both those lines. So we're going to be finding that second equation. When doing that, our first step is going to be to determine our slope and y-intercept, or M and B, of the given line. So I'm going to call those M1 and B1. So I look at my equation y equals 3x plus 2, and I know that this 3 is my M, and this -2 is my B. Now, while that B doesn't really matter other than for purposes of graphing, we still need to make sure we know it to make sure we're checking and comparing our two line equations in the end. Our second step is going to be to determine the slope of the new line. Since we know that slopes of parallel lines are the same, I'm going to call M2, or the slope of my new line, to be 3 as well. Once I've done that, then I can set up y minus y1 equals m times x minus x1, or point slope form, with the m from step 2 and our new point, which is right here, -1, 4. And then that step 4 is going to be to solve for y to get our slope-intercept form. Putting this into point slope form, y stays y, y1 is 4, so y minus 4, because remember, it's always opposite of what you think it should look like because the minus is in the formula. Our new slope is still 3, and then x minus -1, which remember, we think chunky plus, so it's x plus 1. Our next step with solving this is going to be to distribute that 3 to the x and the 1, giving us y minus 4 is equal to 3x plus 3. A lot of you guys draw in these lines to show that you're distributing, but don't actually distribute to both terms, so make sure you distribute to both terms. Finally, we can add 4 to both sides, giving me a new equation of y equals 3x plus 7. Finally, we need to graph this. So I'm going to actually write down my other equation here, which is y equals 3x minus 2. And that way I have them color-coded so I can graph them on the graph according to those colors. Graphing first in purple, y equals 3x minus 2. I know that means I have y-intercept of -2. And a slope of 3, so I'll go up 3 to the right 1, up 3 to the right 1, and then I can connect my points. It is very important that these stay neat so you can tell if they truly are parallel to each other. So if you have a hard time drawing a straight line, please make sure you're using a ruler. Now for our green line. It says we have a y-intercept of 7, so I can go up 1, 2, 3, 4, 5, 6, 7. And it also has a slope of 3, so I'll go up 1, 2, 3 over 1. And then because I'm going to head off the graph and I keep going up 3 into the right one, I'm going to go down 3 and back 1 to get my third point. And then I connect my dots for my lines. Please make sure that they will be parallel to each other. If they are not parallel to each other, please make sure you redo it, because it would be common sense that if they're supposed to be parallel and they're not, that you did something wrong. Moving on to the next example, we have a line that is parallel to y equals x plus 1 through 5, 0. Our old slope, or M1, I see is that coefficient in front of x, which it has a negative sign, which means our slope is -1 or -1/1. And our original y-intercept is +1. The line parallel to it will have the same slope, so our new slope is still -1/1. And we can use point slope form, y minus y1, which y1 is 0, put that in there, equals m, which is -1, times x minus our x1, which is 5. Distributing at -1, we get y minus 0, which I'm going to leave just as y because it just drops off, equals -1x. -1 times -5 is +5. So I will mark the first line in blue, second line will be in purple. So y-intercept +1, slope -1, so down 1, right 1, down 1, right 1, down 1, right 1. And our second line, which I will do in purple, go up 5, 1, 2, 3, 4, 5, down 1, right 1, down 1, right 1, down 1, right 1. Connect my dots. I see that they are parallel, so they look good.